topic. Learning about the structure of an atom. Atomic number. The number of electrons or protons in an atom is called as the atomic number of that atom. It is represented by the letter Z. If you know the atomic number of an atom, you know the number of electrons or protons in it. Look at the figures. The hydrogen nucleus has one proton around which revolves one electron. It means that its atomic number is
Z is equal to 1.
In the helium atom, there are 2 protons and 2 neutrons. As there are 2 electrons in orbit around the nucleus, the atomic number of heliums is Z is equal to 2. Students, now look at the atomic structure of oxygen shown in the figure. Now tell me, what is its atomic number Z equal to? Atomic mass number. We have seen that the mass of an atom is concentrated in its nucleus. From this, we can get the atomic mass number. Atomic mass number, that is A, is equal to sum of the number of protons, that is positive, and neutrons N in the nucleus. Atomic mass number is equal to number of protons plus number of neutrons. E is equal to P plus N. A lithium atom contains 3 protons and 4 neutrons. Its atomic mass number E is equal to 3 plus 4 is equal to 7. In a sodium atom, there are 11 proton and 12 neutron. Hence, its atomic mass number A is equal to 11 plus 12 is equal to 23. Tell me, why are atomic numbers and atomic mass number always whole numbers? Atomic number and atomic mass number give us respectively the number of protons and the number of neutrons together. Hence, they are always the whole numbers. Sulfur atom contains 16 protons and 16 neutrons. Give its atomic number and atomic mass number. When writing the symbol of an element, its atomic number and atomic mass number are also written. Isotopes. In nature, in the case of certain elements, we find some atoms which have the same atomic number but a different atomic mass number. Such atoms of an element are called as isotopes of that element. The nuclei of the atoms of different isotopes of an element have the same number of protons but a different number of neutrons. For example, hydrogen has 3 isotopes. Isotopes are identified by adding the number of protons and neutrons together, a number which is referred to as the mass number. For example, hydrogen. The element hydrogen has 3 isotopes. Hydrogen 1, that is
Also called protium.
hydrogen 2, that is also called as deuterium, and hydrogen 3, that is also called as tritium. Another example of isotopes of that of carbon. Generally, all isotopes of an element have the same chemical properties. However, some isotopes have special properties. Therefore, these have some practical applications. Examples: isotopes of uranium are used as fuel in atomic reactors. Isotopes of cobalt are used in the treatment of cancer. Isotopes of iodine are used as in the treatment of
Goiter.
formation of ions. Electrons revolve
Around the nucleus
in specific orbits. Of these, the electron in the outermost orbit take part in chemical reactions. If the outermost orbit is incomplete, that is, if it can hold more electrons, then there is the possibility of the give and take or sharing of electrons during a chemical reaction. During a chemical reaction, metals tend to give and non-metals tend to receive electrons. For example, a sodium atom has 11 electrons, of which 2 are in the first orbit and 8 in the second. 1 electron is in the third orbit, which is the outermost orbit of the sodium atom. The outermost orbit of sodium is incomplete. When, during a chemical reaction, the sodium atom gives away the outermost electron, the number of
Protons in the nucleus 11
becomes greater than the remaining number of electrons, that is 10. The sodium atom now has a positive electric charge. On the other hand, a chlorine atom has 17 electrons. Of this, 2 are in the first orbit, 8 in the second, and 7 in the third orbit. Thus, the outermost orbit of chlorine is incomplete. To complete it, it must receive 1 electron. When it does so, the number of protons in the nucleus becomes less than the number of electrons by 1 and the chlorine atom gets negative electric charge. Thus, ions are formed by the give and take of electrons. Valency. Every element has a definite capacity for combining with other elements. This capacity of an element for combining is called as the valency of that element. The valency of any element is compared with that of hydrogen, which is considered to be 1. The valency of an element is always a whole number. Sodium and potassium have a valency equal to all of the hydrogen. Hence, they have the same valency of 1. Oxygen and calcium have a combining capacity twice that of hydrogen. Hence, their valency is 2. The valency of nitrogen B3 and that of silicon is 4. The gas argon does not take part in chemical reaction. What do you think is its valency? Its valency is 0. How many electrons could there be in the outermost orbit of the atom of an element whose valency is 2? When atoms of different elements combine with each other, then molecules of compounds are formed. In these instances, it is necessary to know the valencies of those elements. Study the following examples. 2Na plus Cl2 gives us 2NaCl. Valency 1, 1. Here,
the velocity of both sodium and chlorine are 1.
Mg plus Cl2 gives us MgCl2. Valency 2, 1. Here, the valency of magnesium is 2 and that of Cl is 1. 2Al plus 3Cl2 gives us 2AlCl3. Valency 3, 1. Here, the valency of aluminium is 3 and that of Cl is 1. The valency of element M is 2. The valency of element N is 3. Then, the molecular formula will be symbol of elements M, N, molecular formula, valency of elements 2, 3, M3, N2. The valency of carbon is 4 and that of oxygen is 2. Write the molecular formula of carbon dioxide. Formula of water H2O work out of the valencies of hydrogen and oxygen. Summary. The atomic number, that is Z, gives the number of protons in an atom which is the same as the number of electrons in it. The atomic mass number, that is A, is the sum of the number of protons and neutrons. Different isotopes of an element have the same atomic number but different atomic mass numbers. The capacity of an element to combine with one another element is called as its valency. So, that is all in this lesson, students. Keep learning.